Hello, my name is Tolo Chen. Today I'm very honored here to introduce our work, C-Face, continuously reconstructing facial expressions by deepening the contour of the face with the ear-mounted miniature cameras. Facial expressions are very important non-verbal communication channel we use every day to express ourselves to others, and they can be used to analyze people's social and emotional lives. So recognizing this expression can also help the computer to better interact with people. Currently, the most common approach for computer to recognize facial expression is just place a camera in front of the face. However, this method may fail during the mobile situation like walking or other activities. To solve these issues, we can just wear the camera on our body like this. However, are you willing to wear this in your lives? I think the answer is very obvious. So researchers have put forward different kinds of wearable devices for facial expression recognitions. However, most of them are still obtrusive and could affect our daily activities. In addition, they can only classify the discrete expression, and none of them can continuously reconstruct the full facial expressions. So in these papers, we put forward C-Face, a minimally obtrusive ear-mounted device that can continuously reconstruct facial expressions. Here is a very quick demo for C-Face, and the left image is captured by the front cameras, and the right image shows our prediction results using the face mesh model from Unity. Now let me introduce how C-Face works. We found that when people make different facial expression, the contour of the face will change differently. So the main idea behind C-Face is just use the subtle change of the facial contours to continuously reconstruct the facial expressions. We will first introduce our ground truth collection method and then our data pipelines. For ground truth collection, we place a camera in front of the user's face and then use the delete library to extract the facial landmarks as shown here as our ground truth. For our data pipeline, we firstly pre-process the raw image of the facial contour by skin color extraction and binarizations. Then, this binary image is fed into a convolutional neural network framework and then outputs the final facial landmarks. In our US study, we conducted 3 experiments. We conduct study to verify how C-Face performs for the continuous reconstruction task. The remounting study evaluated how C-Face performs after device remountings. Lastly, the face mask study tests C-Face performance while wearing a mask. I want to first introduce our evaluation metrics before diving into the study details. To evaluate the error between the prediction landmark and ground truth landmarks, we put forward a new evaluation metric that we call MNE. MME is the absolute error of only the major landmarks in the most active areas in the face, and as shown in the right videos. In our US studies, we asked 9 participants to continuously repeat the facial expression displayed in these videos. And then we collect the training dataset and testing dataset separately and use all the frame to train and test our deep learning models. Here is the result for our reconstruction studies. On the left is the average MAE across 9 participants, and on the right is the bar chart for the MAE of each participant for both earphone and headphones. Here is the visualization of our reconstruction results to better illustrate C-Face performance. In the middle image, the face captured by the front cameras, and the left face mesh model is driven by the landmarks from deep library, and the right one is driven by the prediction results. In the remounting study, we use the data before remounting to train the model and use the data after remounting to test the models. And here's our remounting results. In the face mask study, the participants won a cut-out mask for ground truth questions for the training data set. And then he will wear a regular uncut mask for the testing data set. And the video on the right just is to illustrate our reconstruction result when the user wearing the mask. Admittedly, C-Face still has room for improvement. For instance, our current model is user-dependent. More people's data need to be collected for further studies. Also, compressed light conditions and the background also affect our segmentations, which could be improved with better software and hardware. We could also work on lowering the computational burden by reducing the data dimensions. Finally, our current ground truth delete only reports landmarks of mouth, eyes, and eyebrows. Maybe in the future, we can apply other higher resolution methods like the iOS does with the Face ID to acquire more detail like the wrinkle and dimples. In conclusion, SafeFace is the first ear-mounted device that can continuously look and draw the full facial expressions. Thank you.